All right, good morning, Algebra 2 scholars. I'm going to teach you two skills today, Skill 19 and Skill 20. Skill 19 you actually will have done in your bell work, so if you pay attention to what we did in the bell work, this will just be a quick little review. But anyway, as we saw in the bell work, the part of the quadratic formula that is under the square root symbol is b squared minus 4ac. So if you remember from the quadratic formula, that's the part that's under the radical. And we call that the discriminant. And I might be misspelling it here, but yes, I am misspelling it. But anyway, so not to be confused with the word discriminate, that is not what this means. But b squared minus 4ac, that is going to be what we call the discriminant. And the purpose of this is it's going to tell us information about the types of solutions that a quadratic will have. So if our discriminant is positive, what that means is we're going to have a value plus or minus the square root of a positive number. So our solutions will be real, and there will be two of them. So there will be two real solutions. And by real, I mean when you consider their graph, they have to cross the x-axis in two spots. If the discriminant equals 0, that means we have the square root of 0. That means that plus or minus won't really do anything. So it's like the plus or minus are gone, and we just have one real solution. And what that means on our graph is that it's going to touch the x-axis in one spot. And if we have a square root of a negative number, we learned that square roots of negative numbers are imaginary. So there will be 0 real solutions. And what that means is when you graph it, it will not touch the x-axis at all. So that's what the discriminant tells us. So we're going to do a couple practice problems with that. So the first thing we have to remember is to make sure that our equation is in standard form. So we have to make one side equal 0. So here we have x squared minus 15 plus 8x equals negative 6. So we're going to add 6 to both sides. And that gets us x squared. I'm going to go ahead and write the plus 8x next because we want it in standard form. Negative 15 plus 6 will give us negative 9. Okay, and we have that equal to 0. So let's identify our a, b, and c values because we need each of those to do the discriminant. So a is 1, b is 8, and c is negative 9. So what we're going to do is we're just going to plug those numbers into the discriminant equation. It goes b squared, so 8 squared, minus 4 times a, which is 1, times c, which is negative 9. So let's see, that gives me 64. And then I'm going to see that I have two minus signs, so that makes plus 36. And we end up getting a discriminant value of 100. So that means there are two real solutions because that's a positive number. Okay. If I look at the next one, again, we have to make sure that one side equals 0. So I subtract 7x on both sides. And I get x squared minus 7x. We're missing a c value, so we're just going to call that 0. So a is 1, b is negative 7, and c is 0. So we're going to use our discriminant. Our b is negative 7, a is 1, c is 0. So we get 49 minus 0, which is 49. This also gives us two real solutions. So all you need to know how to do is plug in those numbers into the formula, and then you're just looking to see what kind of solutions you'll have. Both of these were two real solutions, but if this discriminant value had been a 0, there would have been one real solution. And if this discriminant value was negative, you would have had 0 real solutions. All right, so that's all you need to know about the discriminant. Now let's talk about factoring perfect cubes. So to do this, we're going to start with a little activity where we are going to multiply out these binomials, or actually they're not binomials, but we have a binomial multiplied to a trinomial. What's probably best here is to use the box method. So let's see, we have a plus b, and then we have a squared minus ab plus b squared. And I'm going to go ahead and multiply those out. So we get a cubed for the first one. We get a squared b for the next one. Then we get negative ab squared. And then we get negative ab squared. Then we get ab squared and b cubed. I know that's a lot of a's and b's, but let's look and see what we notice now. If we look here, do you see how we have a positive a squared b and a negative a squared b? Whoops, that actually should have said a squared b, and I wrote ab squared. Let me fix that. And those should cancel out, so sorry about that. And then we have a negative ab squared and a positive ab squared, so that cancels out, and all that's left is a cubed plus b cubed. Okay? And now I'm going to do the same thing with the next one. So again, I'm going to do the box method. This time we have a minus b, and we have a squared plus ab plus b squared. And we're going to multiply so that we can fill in the boxes. A cubed minus a squared b plus a squared b. And then down here we get minus ab squared. And here we get plus ab squared. And the last one is minus b cubed. So now we're going to cancel out any factors that cancel. So those are gone. And these are gone, which gives us a cubed minus b cubed. So what do we notice about the answers we got? They were perfect cubes. So perfect cubes. So we had a cubed plus b cubed, and we had a cubed minus b cubed. So those rules that we multiplied out actually become the factoring pattern for how to factor a sum or a difference of cubes. And so what we're going to do is we're going to talk about that pattern, and we're going to factor a few examples. Pretty straightforward. It's just literally memorizing the, actually you won't even have to memorize these. We're going to let you do this without memorizing the formulas, but just using them. Alright, so to factor sum or difference of cubes, the first thing you want to do is take out the GCF, if there is one. Okay, and we actually don't have to make one side equal to 0 because we're only factoring, so I'm going to cross that out. Then we want to make sure that you have, let's see, make sure that you have a, what did I want to say? Sorry about that little hiccup there. So what I wanted to say is you want to make sure that you have a binomial, so two terms, made up of things that are cubes. And then you're going to find the cube root of each of those terms. And we're going to memorize some common ones so that this will be easy. If you have a plus sign in the middle, then you're going to use this formula. So a plus b. Then you have a squared minus ab plus b squared. And if you have a minus sign in the middle, then you have a minus b, and then a squared plus ab plus b squared. Okay? And if ever you are stuck, I have a little acronym that will help you to remember the signs. I call it SOAP, where the first signs will be the same. So if this is a minus here, if there's a minus in the problem, then the first factor has a minus sign. The next sign is always opposite of whatever the sign was in the problem. And then the last sign is always positive. So that's the A and the P of SOAP. And I'll explain that more in class. But what we need to do now is think of a list of perfect cubes. 1 cubed, 1. 2 cubed, 2 times 2 times 2, that makes 8. 3 cubed, 27. 4 cubed, 4 times 4 times 4, that's going to be 64. 5 cubed, 125. 6 cubed, I don't have that one memorized, so put that in, it's 216. 7 cubed, I definitely don't have that memorized, so I'm just going to put that in on a calculator. 343. 8 cubed is 512. 9 cubed, 9 to the third is 729. And 10 cubed is 1,000. If you know those numbers, you will be able to do all of what we are doing, because honestly, those are the numbers we'll stick with using. Okay, so how do I factor using this pattern? Let's start with our problem here. So we have a cubed minus 8. So we have a minus in the problem, so we keep that same sign when we do our first factor. The cube root of a cubed, so what times itself makes 8 cubed? Well, just a. And then 8, well, 8 was 2 when we cubed it, so 2. Okay. Now I'm going to write the rest of this. So when we're doing our signs here, remember that this sign was minus, so our first sign was the same sign. So the next sign here will be a plus, that's going to be the opposite sign. And this will always be positive. So I'm going to go ahead and start with my signs. And then if we follow the pattern, so if we go back up to these rules, the pattern looks like such. So we take our first thing and we square it. So whatever is the first thing here, we square it. So here I have an a, so I square it, I get a squared. The middle part, we multiply those things. So I take my a times my 2, so that's 2a. And then we square the second thing. So b is my second thing. 2 squared makes 4. That is how we're going to factor that. And it's just going to take some getting practice. If I do the next one, we can divide those by 2x, it looks like. So that's going to give me 125x cubed plus 64. So when I factor that, again, I want to use the same sign as what we started with here. Cube root of 125, well 125 was the cube of 5, so this will be 5x. And then for the 64, 64's cube root is 4. Actually, I'm going to move this over a little bit because I wrote it too far over. Let's try that again. So we have 5x plus 4. Now I'm going to fill in my sign. So if this was the same sign, I put the opposite sign here, and then always positive here. Square the 5x. 5x times 5x is 25x squared. Multiply 5x times 4 to get 20x, and then square the 4 to get 16. So that's the factoring. Don't forget about the 2x we factored out at the beginning, and there we go. Alright, I'll try another one here. For this one, if I look at that, square root of 216, if I go back up to my list, that was 6. I have a minus, and then 27u cubed, 27's cube root gives me 3. And looking at that, you might be thinking, oh, wait a minute, I could still divide those by 3. So good eye. So that makes that become 2 minus u. And I'm going to use the 2 and the u as I finish this out. So I have minus sign here, opposite sign here, always positive here. And then we just finish it out. 2 squared makes 4. 2 times u is 2u. And u squared goes at the end. There's our factoring. Now note that we could have factored out the GCF of 3 at the beginning as well. Alright, last one here. This one is probably the most of a challenge. X to the 6 minus 1. Right now that's a difference of squares. which we talked about in the last unit. So I'm going to rewrite that as x cubed plus 1 and x cubed minus 1. Both of those can be factored as we get x plus 1, x squared minus x. So I'm just following my patterns here. Plus 1. And then for this part, we get x minus 1, and then we get x squared plus x plus 1. A lot of weird factors, but there we go. And that is all that we have to do to factor cubes.